All right, seventh grade teachers, we're going to go ahead and get started. But if you haven't downloaded these documents from these links, go ahead and do so before you move forward. Hit pause and then do that. Okay, we're going to get started on looking at the test item specifications, particularly for seventh grade in the first 9 weeks. What we have here is the test item specifications pages for only the first 9 weeks. I didn't include the Nature of Science standards because not that they're not important, they're super important. I'm believing that the content standards, like the physical science standards in this, will be our influence in figuring out a candidate phenomenon. Now, the Nature of Science standards will be pulled out of each candidate phenomenon, of course, because we're going to get the practice of science and the characteristics of science knowledge and the role of theories, laws of hypothesis, and models during that. But these content standards, this is where we're going to get our inspiration. So the naming convention of a benchmark is the SC stands for science, and the 7 is seventh grade. The P stands for the body of knowledge, or sometimes called reporting category when we get our state standard, our state results back. We have 4 bodies of knowledge. The physical science is P. E is earth science. N is nature of science, and L is life science. The 11 is the big idea, which is our bodies of knowledge and further breakdown in these standards. In this case, it's energy transfer and transformations. And 2 is the benchmark. Well, in 7th grade, the first DIA, the first 9 weeks, we have 11.2 and 11.3 on the curriculum map. Well, you'll notice this is 11.2, but where's 11.3? Well, it's right here because it's also assessed on this with these benchmark clarifications and content limits. So let's go ahead and scroll down and look at those. This standard is to investigate and describe transformations of energy from one form to another. And right here you'll see the benchmark clarifications, and students will identify and or describe the transformation of energy from one form or another. I know you can read the rest of these, but really the content limits are really important. Items will not assess transformations involve nuclear energy. Items may address a maximum of 5 energy transformations. Items will not require calculations. And items assessing energy transformations will not be placed in life science context. Now, this particular standard, or this particular benchmark clarification, does not have stimulus attributes. But what those are, in the case we needed to have some exposure for sure to our students, like if it was a measurement of temperature, for instance, and the state will only be showing temperature scale in Celsius, they would signify it here to let us know that when we give examples in our classroom, we better be giving them in Celsius, because they will not use Fahrenheit in the test or in anything that the state provides. The response attributes define the characteristics of the options from which a student must choose to answer the question. Again, this is in regards to the state assessment. It's good to know that they also provide us the prior knowledge and what years, what grade level, 3, 5, and what the standards are that they have been exposed to potentially to prepare them for this understanding and this knowledge. Some of these lead into sample items. This one doesn't have a sample item, but keep in mind the sample items that they provide in the test item specs documents are released items that were once on the test, and why they're released is because they were poor performing. So keep that in mind. So here's the next one, and this would be for DIA2. You'll see we have P11.4, and on here is P11.1. Those two are the first standards in the curriculum map, and then we'll move on into P10.1, and then last page here is P10.3, which also assesses P10.2. So your goal would be to go through these each and read through the content limits, read through the benchmark clarifications to have a deeper understanding of all of these standards. While you're doing that, it's just natural to start thinking of what phenomenon that is out there could potentially capture my students' attention in order to engage them. The goal would be to find something that could actually spread through all of these. This is a whole 9 weeks worth of content standards. I don't know if you can, but that'd be really cool if we could. Let's try to figure that one out. If not, maybe we just pick one of these standards and figure out a really cool phenomenon that we can get in front of our students. All right, back to the Canvas page, and now we're going to go ahead and just briefly look at the curriculum map, which I know you're very familiar with. But just notice that when we go through these, and when you pick a content standard, so for instance like 11.4, you'll see that it has been unpacked somewhat, but it doesn't have anywhere near as much detail as the test item specifications document. We do a little bit more here in the teacher's hints and instructional focus. Some of the verbiage that you see here will be specifically pulled right from the specs document, but it's not everything. But just because of space limitations and format in the curriculum apps, we're always struggling to try to give you as much information here as possible. The test item specification document is the key item to go to understand your standards, and actually then the curriculum map. All right, let's briefly look at the science practices, page 9 of each curriculum map. This is the science practices where they're all 8 of them are broken down into further clarification. Remember, the QR code links you to a video of Paul Anderson explaining it in more detail. But what I want you to do is, as you're contemplating a phenomenon, when we're utilizing it in the classroom, what can we start having our students do? We definitely know now part of our repertoire is having them develop and use models. They're going to be doing initial thinking models, and part of that process is them asking questions. You may even ask for further clarification in the questioning and have them define the problems in which they need to figure out in order to learn the concept. If this phenomenon leads into an investigation, maybe you have the students plan out their own investigation, lay out the steps they would need to do in order to solve the phenomenon or explain it further. When they do that, they may be having an opportunity to gather and analyze data. They may have some opportunities to do some mathematical and computational thinking. It just kind of depends. But either way, this should result in them either making a claim and constructing an explanation, or lastly, in potentially engaging in argument from evidence. So they make a claim and then utilize the data to support their claim. Anyway, this is just a reminder that this document exists. And don't forget the candidate phenomenon template. You may utilize that to capture your thinking and your notes informally on there in order to derive some sort of idea. But if necessary, you might even utilize that document when you go to the Padlet. Now that's the next page. And here's the 7th grade Padlet. And this, like I explained in the video before, on how you would utilize this, but you may actually populate these with that template if you'd like to. Anyway, I'm super excited about this brainstorm. I know at first, if you're like the first person on here, you're going to wonder, where is everybody? And that's going to happen. But there's going to be an opportunity for you to go back to the home page and access the Padlet later down the road, even after you've completed the course. So keep that in mind as you want to come back and visit this after more and more people have taken the course. I wish you all good luck, and I cannot wait to see this Padlet grow.